Recording in progress.
Okay.
What's your name?
Hi, welcome. Oh, do we know how worksheets? Oh my gosh, also that worksheet. Yeah.
I should have gotten them.
Number 3 or on the.
Soda print room.
Yeah.
Yeah, third floor. No, you can go sit there.
Yeah, I think I said you're.
I think it's right there.
Okay. Yeah. Like, would it be premier, like, or May? Probably surgeon.
I guess, what are you thinking? What's the best I think I've ever come up so far?
Yerba mate.
Yerba mate? Smart. With or without alcohol?
Oh, I mean, up to you. With is fine.
Wait, what else?
Oh, okay, what about like guava ice cream?
I like this.
Yeah. That's interesting. Yeah.
Any other ideas?
Mine was a blue bottle ice cream.
Oh, what?
A blue bottle coffee ice cream, like their ice Nolas.
Have
Have you had this? Oh, what's the ice cream? Okay, this is, I guess I live on the wrong side of campus. They're like New Orleans style iced coffees. And so they have like hickory root in them. They're so good. Highly recommend.
Where can I get them?
Blue bottle next
Blue
to,
Bottle?
like it's downtown.
Wait, I like most of them. Okay.
Blue bottle coffee, have you guys not been to Blue Bottle Coffee? You
I
guys
went
live?
once. I didn't like it.
I like it.
It was a long thing, yeah.
Oh, you remember the Nola?
Oh, wait, there's no Wi-Fi here?
Oh.
Brutal. Okay. All right, anyone else want to share an ice cream flavor that they thought of? I like the yerba mate one. That one's nice. I feel like everyone's addicted to it. Anything else? Okay. Sorry, fill this. There we go. Okay. So, hopefully that was a little good thing to get you guys warmed up, because now we have to start CSing. So, I'm just gonna go over like a few slides and we'll start doing, this is weird. Okay, I can hear my own echo. Yeah, we're gonna go ahead and start doing question 1. Just out of curiosity, how many of you guys are gonna use an electronic copy of the worksheet? Okay, and how many of you guys want a physical copy of the worksheet? Okay, Stella's gonna get them right now, so hopefully, she will be back by then. Otherwise, you can just take a look at the discussion worksheet. It is posted on the website. Okay, so the main topic for question 1 has to do with primitive versus reference types. So primitive types are represented by a certain number of bytes stored at the location of the variable in memory. And there are only 8 primitive types in Java. They're called byte, short, int, long, float, double, boolean, and char. You don't really need to know all 8 of them because most of them aren't really used, but you should know int, double, boolean, and char. These are the ones that you're going to use the most often. The reason that they're called primitive types is because they're really, really easy to store. Like if you just asked Java, like, hey, can you store the number like 5 at like somewhere, like at a certain variable like x, Java can do that in little to no time. It's really, really easy. Whereas reference types are represented by a memory address stored at the location of the variable, which points to where the full object is. And this memory address is often referred to as a pointer. So the examples of this would be like strings, arrays, linked lists, or like some other object that I may create. The main difference between the two is reference types are really, really big. Like I can have an array of size like 10,000. So that means I'm storing 10,000 different numbers. And to like create copies of that would just take a ridiculous amount of time. So it's easier for me to just point to like where that object is so I can reference the same thing. Again, primitive types are small, reference types are big. So I actually thought of like a little example. Actually using candy. So, okay. Let's say I have a Kit Kat, right? Anyone else here want a Kit Kat? Okay. So go ahead and tell me, I want the same candy as you.
Oh, the same candy as you.
Okay. So if I'm Java, what do you think is easier? For me to give her the little Kit Kat that I have in my hand, or just take one of the billion Kit Kats that are in here? What do you guys think? Like, would it make more sense for us to share this, or can I just give her one of her own? Right? Like, I'll give you one of your own. So here, just get that. But instead, tell me I want to use the same bag as you.
I want to use this in bag.
Okay, if I'm Java, what would be easier? For me to just be like, let's just share this one bag that we have, or would it be easier for me to go all the way back to Target, find, which is a solid like half a mile away, buy a new bag for like $6, and then come back and give it to them? Which one's easier? Or we just share this one. What do you guys think? Share this one, it's so much easier. So that's kind of the idea with Java. It does the exact same thing. So if you say I want the same thing as you, and what I'm holding is a primitive type, I'll just give you your own copy of it. Whereas if it's a reference type, it tends to be a lot bigger, like a candy bag, and that would be easier for us to just share instead of making an own copy for yourself. Does that kind of make sense to you guys? Can I get a thumbs up if that's good? Okay, perfect. Are there any questions about this before I move on? Yes.
Examples of routine types. Like those are Java student, like arrays linked list.
Yes.
For the int list class we use in class, is it like view the for CS61B?
Yes, exactly. So the int list class was created by 61B. It's not a built-in type in Java. Yes, linked lists are actually in Java. So anything that we create, so for example, an int list, that would be considered a reference type because we created it. Yeah. Any other questions? Okay, perfect. All right, and here's kind of a quick demo. So basically, if I'm gonna have some sort of variables here, so I have int x equals 5, and then I created an int array, and it has numbers 1, 2, 3, 4, 5. And I'm gonna call the function do something. So basically, notice that do something takes in these variables. Do you guys know what this is called? Any of you is what we call these variables? Yes, exactly. So we call these variables parameters. So anytime we have a variable as a parameter, we either one, make a copy of it, or two, give a reference to that pointer. So x is of what type? You just say that loud. Yes, it is an integer, so it's a primitive type. So do you guys think that would mean I make a copy, or do they share the object? What do you guys think? Copy, exactly. So integers are really easy to copy because it just requires like a tiny little space. It's again like my Kit Kat. So when I pass it in to do something, it's gonna get its own copy of the number x, which would be 5. Similar or unlike that, the second parameter is r, which is an array. So is that a reference type or is that a primitive type? You can say it out loud. Reference, exactly. So does that mean I would make a copy or would they share the same one? Share, exactly. So whenever I make any changes to the other array here, I'm making this change the same array of things because they're sharing the same object. Any questions about that? Thumbs up if that makes sense. Awesome. Yes.
What do you do if you want to copy that?
Great question. For an array, for example, there is a function called like array.copy or something. So there's a separate function which will allow you to create a copy of it. Yeah, but just in general, whenever I'm passing it in, I'm not going to create a copy. Okay. And just to revisit static versus instance variables, static variables belong to the whole class. So for example, every 61B student shares the same professor. And if the professor were to change, it would change for everyone. And instance variables belong to each individual instance. So each 61B student has their own ID number, and that number doesn't change. If I change one person's ID, it doesn't change for every single person's ID. So it's specific to you as one student. So it can be like your age, it can be your hair color, it can be, I don't know, your favorite ice cream flavor, whatever you want. Thumbs up if this slide makes sense. Hopefully it does. This is a revisit of last week. If not, feel free to ask. Okay, cool. All right. So The first question for today is called static electricity. Out of curiosity, any Pokemon fans? One? No? Pokemon? No. Okay. But this entire question is based off of Pokemon. So you'll have like a bunch of Pokemon trainers, but hopefully you might recognize some of the names or images. Should we give them time to work together or?
5 minutes.
Okay. So I'll give you guys around like 5 minutes. So maybe like look through, try to get a feel of the question. Maybe try figuring out like part A if possible. And maybe work in groups so you guys can talk it out. And then I'll start going over the answers myself. So go ahead, can you pair them up maybe or
What?
pair them
Yeah,
up?
let's
Or
pair you guys up so you can find spots, like how it does compare. And then what you, and two are together, all right, you guys. There you go. Oh, here you go. Okay, me too. Just like each minute per shop, and then talk about like what's
did you disconnect this or?
Yeah, I think we can also
Oh.
connect it to either your iPad or the this, whatever works better.
Okay, I have it here.
Okay, perfect.
So like, okay.
Yeah.
Although I don't know if people are gonna get it because no Pokemon fans.
I know, those are so cute.
I know.
Are you screen sharing with this or could you screen share?
I'll be fine.
Yes. Oh.
Yeah.
Oh, maybe you need to turn your audio off. Yeah.
Hello?
Okay, cool.
Any
I think.
echo? Well, I don't even know if it's receiving it.
Does it like go up? Oh, I
Yeah, it's not even going up, so.
test. Okay.
Wait, so is the
Yeah.
first one on 27?
The midterm?
Yeah.
Oh, that's on the website. I'm sorry, I don't know.
I think.
So doing vision and all, like, you just have to add all these language.
All right, can you guys see this? Let's get started. Let's not waste any time. So we're gonna go into linked lists. And hopefully you learned a little bit about this in lecture. We're also gonna work a lot with this in project 1A. And so I'm not gonna go too much into it because you're gonna get some practical experience. We only have one slide of mini lecture. I think getting into the problem will be the most helpful because there probably will be a linked list problem on your exam. And a lot of the time it will be something similar to this problem on your worksheet. So I encourage you to pay attention and listen. I'll show you the strategies I use and hopefully you can ace this one on the exam when it comes around. So starting out, like linked lists, what are they? They're kind of like modular lists made up of different nodes. So I like to kind of think of them as like people holding hands, kind of. I know that's kind of maybe a bad example, but like they're holding hands that are little like links. And so a linked list has different nodes that are connected to each other. Linked lists can have like pointed nodes to each other. And yeah, they're a great data structure in Java. We can use them to represent all sorts of stuff. I'm trying to think of like a practical example, maybe like you have different like classes you're taking at Berkeley, like say this is like 61A node and this is a 61B node. You could use like a linked list structure to denote like, you know, you have to take classes in this certain order. So linked lists are actually super great for coding and in Java. And so they can be extended and shortened by changing the pointers. So we could just add another pointer, add another node. This is unlike the arrays we talked about last time where arrays were a fixed length. You couldn't add to them. So that's a huge plus of a linked list. But on the other hand, they can't be indexed directly. So we have all these nodes in this example here. We can't just say like linked list at position 2. That doesn't work. Like we don't have that power anymore because we only have access to this first node and then we need to hop over to get into the other ones. So you can't index into them. Lastly, I did want to touch on this sentinel concept. How about like thumbs up if you understand what this is, thumbs side if you're like, maybe I heard of it once, thumbs down if you're like, what the heck is that? Okay, a lot of all over the place. So a sentinel is a very special type of node, and it's kind of like an empty placeholder, just to make like adding and removing things easier. So say I was like making a new linked list like this, and I'm calling it linked. Points here. The sentinel usually is this first node, so I would like highlight it this other color, and it's kind of like a placeholder. We don't put like anything important in there. Usually like the value in it is just null, because we don't really care what's in there. It's just kind of like a starting point. And then the actual values would start after that, like 1, 2, etc. So think about it just as a placeholder. You'll see in project 1A how it's super helpful when we're working with things. But for now, just know that like what's inside of it, we don't really care about. Cool. Any questions about linked lists? Okay, great. Let's get into the problem. I think the problem is the most useful. So this problem is called cardinal directions. I know there's so much code here. So let's unpack what's going on. Basically what they're asking us is to draw the box and pointer diagram that's going to happen after all this code runs. There are so many exam questions that are this exact format. Like, please pay attention. These trip you up on purpose. You have to really pay attention to details. But these are something you can really master for the exam. Like I hope everyone here gets this like 100% on the exam because it's really just drawing and keeping things organized. So if you have everything organized and you understand how linked lists work, you can ace this. But let's get started and look into what this code is. So let's just go line by line. That's what I do. I just kind of read top to bottom, understand what I'm working with. We can start off by seeing that this is a DLL string node class. Okay, cool. Working in this class. And then we have 3 variables. We have a previous, and you can see this is of type node. It's a DLL string node. So we have a node previous, we have a string s, and then another node next. So those are the three we're working with. We have three variables. We also have a constructor. This is super helpful. So you see, if we want to create a new node, we have to pass in a node as the previous, pass in a string, that's like the contents of the node, and pass in a next. So what I like to do is like seeing kind of like a new class. I've never worked with it before. I like to kind of draw out a picture of what we're working with. So I'll call this is a DLL string node. And remember, it had those three properties. The reason I drew it as a box is because it's a node, and I think like nodes are good represented as boxes. You could have also kind of drawn like a circle as like a node. And remember, this node has three variables. So I'm going to split it into three. And so the first one was the previous. And then we had the S, this was the string, and then the next. So that's kind of how I'm going to represent a DLL string node. This is like the typical representation of what a node looks like. If you've been to lecture, a lot of nodes are kind of this rectangular space. And remember that pre and next are of type DLL string node. That might be a little confusing. Like, how do we like put another, like, are we going to put another box in there? Like, that doesn't make much sense. But remember, this is a reference type. So like arrays, reference types like DLL string nodes are going to be a pointer. So like from pre to next, this is going to be pointers pointing at other nodes. And then the string itself, we can just put inside whatever the string will be. So the pre will be pointing at something, next will be pointing at something, string will be some string in there. So that's the basic structure of what we're working with. Any questions on these lines here in the structure? Okay, yeah, question.
Is it because this is a DLL? Otherwise, because normally we only have like one way.
Exactly, yeah. Normal linked lists we've seen before, like I showed you on the last slide, they only have that one way. But because we're working with this special type of node, DLL string node, this DLL actually stands for doubly linked list. So doubly means two, like double. So we have one coming out the front and one coming out the back. Yeah, it's a special type. Yeah, questions?
Strings are references in Java.
So yeah, strings are a reference type, but we don't really use a pointer for strings. They're kind of like, you just kind of put them in that location. Yeah. Okay, well, let's move on to actually doing the code. So as you see, we have this main method. That's where all the code is run. I always like, go straight to wherever that main method is. I know that's where my code is going to be run. I'm going to start on that line underneath it. So let's work through these lines. These are optional practice, so those are for you on your own time, but let's do these ones together. And let's start at the very beginning. So whenever I see like a line like this, that's an assignment, usually I'll focus on creating the right-hand side first. So I'm going to create this and then assign it to this variable. So let's do that. The first step is we're making a new DLL string node, and the previous is null, the string is e, and the next is null. So let's draw that out. So we have a new DLL node. Remember, I'm representing that as a box. The previous is null. So for null, I'm just going to do a little strike through. You could have also totally left it empty. And then the string in the middle is going to be e. And then the next is going to be null. So I also did a strike through. So I evaluated this right-hand side, but now I need to assign it to the left-hand side. So we can see that we're making a new DLL string node that we're calling L. So in our little environment diagram here on the right, I'm going to have L. It's going to be pointing to this. Any questions on that first line? Okay, bear with me because things are going to start to get a little bit complicated. So let's lock into this next part. So this next step, let's say we checked off this line. Now we're working on the next one. We're going to first, do the right-hand side, then assign it to the left-hand side. So working on the right-hand side, we have a new DLL node. And then the previous we can see is null. So that's pretty simple. The value inside of it is bananas. I'm just abbreviating it. Sorry, I can't fit it all. And then you can see that the next is L. This is a little confusing, right? Like what do you mean L? So we're gonna have to go to our environment diagram, see what L is pointing to. L is pointing to this node. So we're like, okay, because this is a reference type, we need to point our next to that node L. Then we need to do this left-hand side. We're reassigning L to be this new node that we made. So we're going to delete what L was assigned to before and reassign it to this new node. Yeah, questions?
What stuff is the second or first one created, the path of that one is due null, even though we're pointing to that first.
So we can see that like both of these nodes, their previous are both still null. It's just like this one, this node's next is now pointing here. And L is now pointing here, but the previous are still null.
Then you're actually pointing to null placeholder.
We're pointing to like the entire object. So you can kind of think there's like a bubble around this entire thing. So we're not just pointing to this like prev square. We're not just pointing to that square. We're pointing to this entire node.
Abstract.
Yeah, like a big node of like all these three values. Does that make sense? Yeah. Any other questions? Okay, for like the sake of it looking pretty, I'm gonna rearrange this. As we can see, we have like the banana one now first and the eat second. So I'm just gonna make it look a little bit nicer. This is for my own sanity, so that it doesn't start getting super messy. So like this. Sorry if this is confusing. It's the same as what we had before, just a little bit more organized. Okay, now that we've done that line, let's move on to the next line. So the next line, you can see we're going to first evaluate the right-hand side. We're making another DLL string node. Like, oh my gosh, how many nodes are we going to make, right? So let's make this new node. And then we can see that the previous, this first one, is null. So that's just going to be a dash through. In the middle, we're going to have never, this string. And then we can see the next is going to be L. So we do the same thing as we did before. We're going to go look at our environment diagram. We're going to see L. Okay, L is right here. What is L? It's a pointer to this. So our next is going to be a pointer to that. Then we have to assign L to this new thing we made. So we're going to delete what L was assigned to before and make it assigned to the new one. So you can kind of see like in the past two lines, we did the same thing. We just kind of inserted something to the front. So it looks like it was really, really complicated, but we were just inserting to the front. Okay, any questions here? How are we feeling about this so far? Like thumbs up if like, okay, we got this. Thumbs side if like, okay, this is a little fast, I'm a little confused. Thumbs down if like we need more explanation. Okay, cool. Let's keep moving. Let's keep doing this together. Okay, next we're going to work on this line 14. You can see we're creating another DLL string node sometimes. So let's do that. New DLL node. I'm gonna call this sometimes. And then the previous is null. And then the next is L. So we're going to see, okay, what is L pointing to? This one. So our next is going to be pointing to that. Then we're going to reassign L. And I know this looks really messy right now. Ooh, to that. So I'm just going to rearrange this to make it look a little nicer. L's over here. This is the first element. Sometimes, and then we do never, and then banana, ooh, and eat. Sorry, I know this is getting super messy. They don't really give you guys enough space for this. Cool. Does that make sense where we're at after those lines? Nice. Okay, so let's keep working now. So things are going to get more complicated. Let's look at this next line. Now, this is a different format than what we've seen before. First, we're going to look at this right-hand side. We see that we're going to be assigning something to L.next. Like, wait a second, like, what does that mean? So first, let's go take a look at L. So L is pointing to this entire node. So this is L right now. And then we need to look at what is L dot next. And so sometimes I like to just like label these just for my own sanity. So this one is the prev, this is the S, and this is the next. So when we look at L dot next, we first go to L, we see we're working with this, and then L dot next is this pointer here. So what I like to do is just like highlight this in another color, like this here, this node, this pointer is what we're going to be assigning that to. That is L dot next. And then we see on the left-hand side, we're setting that to a new DLL string node M. And so when we have this like new DLL string node, we're not actually using the constructor. So we're not going to make a new square. We're just going to make something in our environment diagram, M, and it's going to point to where that green was. Any questions there? Yeah.
If you do like print or return L, like would you only see that first node, or would you see like all the nodes linked to it?
Yeah, it's a good question. So if we did just like print L, because L is like a pointer, that's like a reference type, it would just like print out a bunch of gibberish. It would just be like that location in memory, be like 01, like 876 at symbol, blah, blah, blah. So we would need to like loop through each item and like print out what's inside, because you can't necessarily like just print a pointer. You'll just get a location in memory.
But that's only for that like first node, right? Like that first, does it like link with all the rest of the nodes, or is it just that one single node? Like, does that make sense?
Yeah, so L is just pointing to this first node here. And then if we went into like L dot next and index that, then we get into next. So I think, yeah, you're right with that logic. Okay, let's keep moving. So next we are going to work on this line. So first, going into the right-hand side, we can see that we're creating a new string node. So woo, yay, now we got to use our constructor, make a new one. We can see that the previous and the next are both null, and then inside we have shredded. Super weird that I don't know who named all these nodes, they're super strange. And then we're setting that to R. This should be kind of a review of that first part we did. And then the next step, we're going to first evaluate the right-hand side. We're going to make another new node. The previous is going to be null. Inside, we're going to have wheat. And then this next pointer, you can see we're pointing at R. So we need to go in our environment diagram. Where's R? Not here, not here. It's right here. We're going to point to what R is pointing to. Then we need to reassign R to be that new node. So just to make this look a little bit nicer, I'm going to move it around. I always recommend kind of making things cleaned up after you do a step. So R is pointing to wheat, this node, and then this wheat node is pointing to the cheddar node. Oh, shredded node, sorry. Cool. Any questions after those two steps? Yes. Yeah, so when constructing a new instance, you'll always use the new keyword with a reference type. So like same as like when we're making a new array, if we're making a new dog object or a new cat, even a new node, we always use that new keyword. And that's just specific to Java. Yeah.
We do not have the keyword, so is it necessary, or like in which circumstances do we, use or not?
Yeah, so remember what we did for M is we just created this variable in memory, but we didn't create a new box. Remember those new like boxes that we're creating? That's when we are using that new keyword. If we just want to create a new variable, that's totally fine. We don't need to use the new keyword. It's when we're creating a new instance, like the actual box.
So does it have anything to do with the copy concept?
It kind of does, because we're just like using this like pointer and we're pointing at something. Yeah, question?
Why can you set the previous or the next to null? Because it seems like to me it's it should be
A node. Yeah. That's a great question. So the question is like, oh, why can we set it to null? So you can always like do that and like set this to null, but it's not the best approach. Like if we were actually doing like some real life example using the doubly linked list, we probably wouldn't want to have all these null values. We'd probably want it to be like, double pointed in different directions. But for the sake of this example, you're totally allowed to set them as null.
Well, I guess another, okay, I want to.
Yeah.
rephrase it. So the type of a pre or next is double linked string node,
Yeah, the
But-
type of prev and next is that, that node.
but no, it seems to me it's not. Well, I don't know how to categorize it, but it's certainly not double linked string.
Yeah, no, great question. So it's like, oh, wait, we need it to be a DLL string node. So we can actually use null here. Null doesn't have a certain type, like we can use it when we don't really know. And so like null is totally fine to use. It's kind of like a thing in Java that we use when we have no idea like what it actually is. So it can be used here, even though it's not necessarily a DLL string node, which I completely agree. And I know that's a little confusing. But we can use null when we just don't know.
So can null be assigned to any type, like you can.
Yeah,
compare it
other
to
reference
string?
types can also have like null assigned to them as well. Yeah. Okay, let's keep moving, guys. So this next step, we are going to first look at these right-hand side and say, okay, we are going to be assigning something to R. So I like to go with my green pen and say, okay, we are going to be assigning that to whatever R is. But then what exactly are we assigning? R.next. Like, oh my gosh, now things are getting confusing, right? So let's go into R. And so we see R is pointing to here. And sometimes I like to just label this. So R.next is pointing at this. This is R's first next. And then next again is this one here. So R.next is pointing here. And then the second next is here. So we're going to be assigning this. So I'm going to delete this little null. This is no longer null. And I'm going to assign that to what that green was pointing at. Boom. That's a little confusing. Now it's an entire circle. But that can totally happen. Any questions there? Yeah.
So if you change the order of this code, making it R equals R.next, is it going to make it just null for R?
Yeah, exactly. Like if we like flipped it around and we were like R is assigned to R.next, that would be, just like nothing there, null. So yeah, it would just R would point to nothing. And you can experiment with this. I think there's more examples down here that might do stuff like that. So you can experiment with that too after. Cool. Okay, now let's do this next line. First, I like to work on what's on the right-hand side. We can see that we're going to be assigning something to R.next. So let's go into R. And so R is this node right here, and then R.next right here, and it's pointing to here. So I'm going to put my little green arrow there. That is that target. Now I'm going to work on what's on the left-hand side. Oh my gosh, this is getting a little confusing, right? So many next here, but it's okay. We can do it. We can follow it. So let's do it. So first, we'll go look at M, which is here, and then we can label this as its next. And so then we're going to go one more, look at that one's next. And then we can go one more and look at this one's next. So we've done 3 next. So this is our target one that we want to assign. So we can delete this little null space here and bring an arrow down and point it at this node, our target node. I know I went like super fast. I think it's always helpful to kind of label, like I did labeling of like 3 next. So I can kind of keep track of like M.next. I think that's like super helpful. It's always important too to like you do this little like green pen target destination because you always evaluate the right-hand side first. Yeah.
So, I understand how you got M.next.
Yes.
But when you assign R.next, wouldn't it be the first box, like pointing to the next?
So this first box, this is R, and then .next is here, this like next, and then that's pointing to here. So that's why we assigned this one to this node here.
Oh.
Yeah, great question, great question. Yes.
So is it Is R now kind of looping forever?
Yeah, so you can see R, yeah, it's just a forever like infinite loop. And that's like totally fine for linked lists. A lot of linked lists have that circular structure.
And if we add this into m.next.next.next, it will make m also the infinitely looping.
Yeah, exactly. So now M is also doing like a loop, infinite loop there. Cool. Okay, last one, guys, almost there. This is probably the hardest one. So we're gonna be assigning it to L.next. So let's go take a look at L. Here we go, it's right here. Dot next, now we're pointing at this one. Dot next, now we're pointing at this one. Dot next. So right here. So L.next. So this is gonna be the target, whatever this is pointing to. Our target there. And now we're going to be assigning L.next to that target. So let's go look at what L.next is. So we're going to go into L, this node, dot next. Now we're pointing to this node, and then dot next. Now we're here, this pointer. So we're going to erase this pointer. We're reassigning you to our green target. So what you can see we did with this is we are now just like skipping over this node completely. And this node is actually just going to kind of like disappear into space because there's nothing pointing at it. So in Java, it's just going to kind of garbage collect that. It's going to say, oh, nothing's pointing to that. No one could ever access that. So it's just going to kind of disappear into space. You see how we could like never use any L or M or R to get to this node. So it's kind of like disappeared. But you can leave it up there. Like if this was an exam question, you can leave it there and that's totally fine. Okay, cool. Yes, last questions.
So, I think the instructor mentioned something like memory of when you store it. So even though it disappears into space, isn't it still isn't it still in the middle, not there anywhere?
Yeah, it's like somewhere, but I think Java actually is like pretty smart that it'll like get rid of that memory at some point. But yeah. Yeah, another question.
Before L.next was pointing to. L.next was pointing to the banana one, right?
Yeah, it was pointing here.
So why wouldn't it point to that?
Yeah, that's a great question. So we first found our green target before we even assign this. Like we can go back. First we look at what's on the right hand side, like what we're assigning it to. And so we're assigning it to L.next. So we're 3 next there. So L.next, this one, next, which is pointing here.
Yeah.
So our green target is going to be pointing at this node.
Yeah.
And then this is the one we're reassigning. So we're going to kind of like hop over that node. So this was what was on the left hand side, and that's on the right hand side.
But okay, so sorry.
Yeah, no worries.
Next is pointing to something, so that's like our target, but like for next, we don't use the target, we use like where it's coming from.
So like the target is like this, like next here,
Yeah,
and we use like what that's pointing to, which is this node.
yeah,
So we don't just point it like to this square, we
Yeah.
point it to like what that's pointing to.
but for like next, we don't use what it's pointing to, we use the square.
Yeah, exactly, because you're reassigning it. We're saying, okay, you're just gonna get reassigned on the left-hand side. Yeah, that's really great. Okay, cool. So let's do like a 2-minute break really quick. And then we're gonna get into arrays. We're gonna switch back. So just like 1 minute to refresh your brain, 2 minutes, and then we'll get into the next one. Yes, we do. We have
Yeah, I found it.
Oh, I need to, yeah, that works. Oh, do you too? Yeah, it's words. Yeah, exactly like that. I think so. This one is like, you need to. Yeah, that's why I took. Yeah, dude, I don't think even students like it.
There's like, there's like 4 mods, like
There's a
mods
list,
to do.
yeah.
Not 4, 2, but like, like, you have to like think about the math. Oh, okay, well then, wait, then they're teaching the same thing. Okay. I think.
They use it here. Oh.
Okay.
So you. The team note.
I think I need to hop back in soon.
Oh, yeah.
I think I accidentally exited this.
And
Yeah,
then
you can do the
public
same thing,
speaking
so
something.
probably, if you want to, you can just share your screen too, if you want to, so we don't have to change the plug.
Yeah.
But we can also just plug your thing into.
Oh,
I think.
yeah, I can share my screen.
Thanks.
She's like, okay, yes, it's like.
And feel free to use this.
Okay, okay. I probably should have done that from the start.
I think you need a previous to introduce teams. Okay.
There was something like this.
Okay, guys, we're gonna start out with question 4. We're probably gonna use the rest of our time to do this question. I know this one's a little more scary because it has some like actual code fill in, but this is also like a very similar like exam question. So I think it's good to just think about strategies for how to go about problems like this. So please keep your attention focused if you can.
Yeah, so it's always really good practice to get familiar with writing a little bit of code. Because a lot of times on exams, we do like putting some amount of code on it. So is there echo on this? It's fine. Okay. So question 4 is called gridify. So basically, you're gonna get a other way. Okay, you're gonna get a circular sentinel implementation of an SLL of nodes. So very similar to what we went over with question 3, but this time instead of doubly linked, it's singly linked. So we can only go forward